In a previous video I showed you this magnetic motor. The working is very simple. The current enters here to this magnetic switch and from the switch to the coil. When the coil is energized, the axis moves to the left and the switch opens. So no current flows through the coil and the axis returns to the right. But this closes the switch again and the cycle repeats. This means that in the coil we have a train of DC pulses. The current in the coil looks like this. The current flows when the switch is closed, then goes to zero when the switch opens, then the switch closes again, the current flows, etc. This looks like a kind of alternating current, so a subscriber of the channel, Obvious Ninja, suggested that we may use the current flow in the circuit to drive a transformer. So I decided to make the experiment to see what happens. Here we have the transformer connected to the motor circuit. The transformer is in series with the motor. The positive of the power supply goes here, goes through the transformer, through the magnetic switch, then to the coil, and from the coil to the negative of the power supply. This is the secondary of the transformer and this is the primary, this is the output. So the transformer is connected as a transformer that rises the voltage. Okay, let's see what voltage we obtain at the output of the transformer. I'm going to turn on the power supply. The motor is now working and we can see that the multimeter reads a little above 2 volts AC. However, let's see what happens with these 3 neon lamps in series. We can see that the 3 lamps are turned on. These small neon lamps require a minimum of 70 volts to work. Therefore, 3 of them in series need 210 volts or more. What happens here is that multimeters are calibrated to read an AC of a frequency of 60 Hz with a sinusoidal wave. Since we are obtaining a square wave from the output of the transformer, the multimeter gives a false reading. The fact that we are getting 3 of these lamps to work in series indicates that the transformer has an output of above 200 volts. Another problem with this circuit is that the current that goes through the coil is very low. This is the same current that feeds the transformer. Therefore, the output power from the transformer will also be very low. Let's try to turn on this LED lamp, which is only of 3 watts, to see what happens. As you can see, we only get some flashings from the LED lamp. This indicates that the power is not enough. Okay, so there you have it. Of course, this has little practical value, but I think it's interesting to see how you can drive a transformer by electromechanical means. Hope you liked the video.